And after working on the blocking on the wedge, now reset the blocking index control, and this will display again all the blocks in the domain, all the edges also. And for a time being, just hide the pre-mesh from here and also hide the curves and points. And if you take a look on the blocking, you can see that the blocks inside the wedge, they have the shape of the wedge, but on the downside, on the bottom side, and on the upside, they are on the some distance from these vertices. So I will correct them, I will make them in a one line. So I will go to the move vertices. You can do it manually by setting the location for the one vertex, let's say from here, and then just modify in this case we need to modify the x and y of these vertices one by one. So let's say I can do it in this way, and this will make the correction also, but I have to do them one by one for all of them, and there are many. So what I will do is that I will just go to the third option, which is here, and I will choose this edge inside the wedge here, and any vertex on the upper side, on the downside, and after that I will click on the apply, and this will just align them in a straight line automatically by this direction. And after doing it, now the next thing is that we will create the Y mesh or the quadro grid in this block, in this region. Let me show you. This is a triangular region, so I want to have the hexa meshing here also. So just display this block region. So choose these corners in this way, and after that go to edit blocking from here, and in the edit blocking, the fifth option in the first row on the right side is a convert block type, and there are the many options you can convert them. Right now we have the wedge block, or we call this one as a prism block. You can see that we have the mesh like prism here, this one. So these are prisms because we have the triangular up and down side on the bottom and top side of this block, and on the sides we have the hexa meshing or the rectangles. So I need to convert this one into the Y block. So again display the blocks, these three blocks, one inside the geometry, so you have to display the solid also. I will change the type of the block to the Y block here, and then choose all three blocks from here. You can choose them in a one go from this toolbar. So I will click on the look at or select all appropriate visible objects and click on here, and this will just convert them into the Y blocks. And now hide these blocks, but before that I want to just give the number of nodes or the pre-mesh parameters. So let's say put the number of nodes here 14, and on this edge I will put the number of nodes as a 14. Apply, again confirm here, and also here I will put the number of nodes as a 14 and apply. I now hide the blocks and check the pre-mesh, and also hide the solid block from here, and when you output the mesh, it should be hidden from the view in the parts. Otherwise this will also be exported in the mesh, and we don't want to get the mesh inside the wedge because the flow will be over the wedge and not inside the wedge. So now you can see that we have a very high quality mesh, full hexa mesh in this triangular region also. And now I'll go and I will decide about the number of nodes on these sections. So let's say I put the number of nodes as 100 or maybe 60 here, and you can see that the arrow on these edges, they are pointing from this side to this side. This is side number 1, this is side number 2. So I need more refined mesh on the side number 1 because we'll have the wake region here. So let's say I put the size as a 0.01, ratio is a 1.1 or 1.15, and I will choose the geometric one because this will make the more grading towards the side one. And by geometric will make the grading on the both sides, and geometric 2 will make the grading on the other side of these edges. So I will choose the geometric one, apply, and now display the pre-mesh. And now you can also, if you show the top, you can see the same mesh on the top side, and from here you can observe that thing that we have the very fine mesh in the back region. And from here I can decide about number of nodes on these sides of the wedge. So let's say I make them 24, and also here 24, apply and right click on the pre-mesh, and again click on the recompute. This will enforce a new spacing, new number of nodes, pre-mesh parameters on your geometry or the blocking in this way. And also we need a more defined mesh at the inlet region, so I will first copy the sizing from this side to this side here in this way. So first choose the reference edge, which is the one of them here, like this. This might be, and then here, or maybe here and then here. So any one of them, these edges can do the work as a reference edge, and target edge is the edge where you need to define the spacing from these neighboring edges. And now define the spacing also here. So number of nodes, let's say I put as a 30. And this time it is telling me that the side number, spacing number 2 is here, and spacing 1 is on this side. So I will go for spacing 2, which is already copied from these neighboring edges, and ratio as a 1.2, and apply, and again check the pre-mesh. And similarly, I can copy the parameters from this edge and here in this way, and this time I will put the geometric 1, geometric 2 in fact, because it's side number 2 here. And this time I put the ratio, very low ratio here, maybe 1.02. I don't want more grading on the wedge. And then copy from here and then here, and again apply the same spacing on this side of the edge and recompute the pre-mesh. So maybe we need more nodes here, so let's say make it 40, apply, and right click and again recompute the pre-mesh in this way. And similarly I will copy these parameters to these edges in this way, and make number of nodes 40, and the spacing as a 1.2, and the law as a geometric 1, and similarly do them for all of the edges here to make the boundary layer more towards the wedge geometry, so we can capture the boundary layer. So we need more nodes, that's why I'm just clustering the more nodes towards the geometry of the wedge. And after making the adjustment to all the edges, now you can see the mesh. You can hide the edges from here and also the points. Now this is a mesh on the geometry of the wedge and as well as in the domain. And now you can check the mesh from inside the domain by right clicking on the pre-mesh and click on the scan plane and choose any edge where you want to see the scan plane. This is how the mesh will look like inside this domain on this location of the edge. And similarly on this location of the wedge, the mesh will look like in this way. And also I can change the color of the this plane from here. Just click here and show or choose any color you want to display in this way. And also I need to see that if I hide this plane, so I should have the fine mesh along this side also. So I will copy the spacing from here to there, and also from this side in this way. And then I will choose this edge, and now I will apply these all parameters to all the parallel edges across this line, and apply here and right click on the pre-mesh and recompute. And now I will check the pre-mesh from inside. Now they are applied, as you can see here. And now I will check the mesh quality from here, and first determinant 2 by 2 by 2 should be greater than the 0.3. Apply, and its value is 0.84, and the minimum quality, it should not be less than that, is the 0.3. And second thing is that the angle should not be less than the 18 degrees, so it should be greater than the 18 degrees in the whole domain, and we have the minimum angle as a 19.98. And now mesh is ready, and now we will be exporting this mesh to the Fluent, and with the boundary condition with the solver. So right click on the pre-mesh and click on convert to unstructured mesh here, because the Fluent or CFX, they are unstructured solvers, so we need to convert this mesh to the unstructured solver. And then from output mesh, choose the solver, which is a Fluent here in our case. Apply, and then click on the boundary conditions, and I will define the boundary conditions as, for the bottom I will choose the wall. So I can define this condition by click on create new and then wall here. And similarly for the inlet, this is the pressure far field. For the outlet, this is the pressure outlet. For side one, this is again a wall. And if I delete this boundary condition, I can create new one, and also I can, if I click on this wall and copy from here, I can paste this one in the side one or any boundary I like. So let's say paste here, and also similarly here. This is what we can do here. And now click on accept, and after that click on the export mesh, and this will open the panel for the export mesh. And from here click on open, and here the panel for the mesh export. You can put the name as the, let's say, Wedge workshop 7, and click on done. And this will be in the now in the D, because we have saved the project file in the D. So this file will be in the D. So we have the workshop Wedge workshop 7.msh file. And here I've just launched the Fluent from the start menu, and here I can choose a working directory, which is a D here, and it's a 3D solver, and you can choose a double precision if needed for the more accuracy. And it's a parallel version, and I will use all the 4 cores because this has 1.3 million nodes or around that mesh, depending on the number of nodes you define on edges. So in your mesh, this can be slightly less, it may be slightly more. So maybe you have the 1.2, maybe 1.1. So it doesn't matter. But it should be on the same scale. On the overall looks of the mesh, they should be on the same as the shown in this tutorial or the workshop. And then click on OK. And from the file menu, click on read mesh file, and read this mesh file Wedge ws7.msh file. And this has a 1.7 million nodes. So maybe we have to make some less number of nodes on the free stream on the side. So maybe instead of 40, you can make it 30. On the upper stream, you can make it 20. On the downstream, you can make it like from 60 to 50. So this will reduce the number of nodes in the overall domain. So first click on check, and the only thing you should be worried about is the minimum volume. It should be a positive quantity. This can be a very low number. It should not be zero or negative quantity. The port quality, and we have the minimum orthogonal quality as a 0.34, and the 0 is the worst and the 1 is the best, so it should be greater than 0.01, and but we are at the 0.34. It's a very good quality. Aspect ratio is 145, and it should be less than 1000. In the boundary layer, in the normal flow, it should be less than 100, so it's okay with us. And in the next part, I'm going to solve this problem in the Ansys Fluent with the boundary conditions I provided in the problem description.